Okay, so I'm going to go through here how we can use two different ways when we're using our BPD. Okay, this stands for Binomial Probability Distribution. Okay, so we're just going to look at one example from question 2 and one example from question 3. Okay, so if the births of boys and girls are assumed to be equally likely, calculate the probability that in a family of 6 children there are exactly 2 boys. Okay, now we use the binomial probability distribution when we're calculating a single event only. Okay, so for example, if you were flipping 10 coins and you wanted to know 6 heads, okay, exactly 6 heads, what's the probability of exactly 6 heads occurring? So a single event only. Alright, out of 6 kids, 2 are boys. This is a single event only. Alright, the probabilities are equally likely. Okay, so there's 2 ways we can do this. The first way is using combinations. Alright, so what does that look like? That's going into our run map. And we're using, in option across probability, this thing here, NCR. Okay. Now our number of trials is 6. So out of 6 children, we had 2 successes or 2 boys, and then we multiply that by the probability of it being a boy to the power of how many boys, and then we multiply that by the probability of it being a girl, which is also 0.5, and that's to the power of how many girls there are. Okay, and there's a couple things you can notice about using this. Alright, is that the probabilities, the point, whatever the probability is using there and there that my mouse is circling, they will always add up to 1. Okay, and the number of successes and the number of failures will always add up to the total number of trials there. Okay, and we just execute that to calculate that. Okay, so what we put in here is okay, that's what we put in our calculator, and this is equal to 0.2345. 2344. Okay, now the second way that you can do this is using the Bpd function in your calculator, in your statistic menu. Okay, so the way we do that is we go to menu, stat, alright, we go in there, distribution. We're not using a normal, we're using a binomial distribution, and BPD because we're only calculating a single event. Alright, make sure this is set as variable. We're not using any data from the lists. Okay, so change that to VAR for variable. Okay, our X is the number of successes, so we've had exactly 2 boys out of 6 kids, and the probabilities are equal, so they're both 0.5. Okay, and we calculate that one, and that'll give us the exact same number. Okay, so to get full marks for your answer, you're going to need to put all of this information in. So you'll have data, variable, n, number of trials, 6, the number of successes, 2, and the probability. okay, and the result that we get, the probability equals 0.2344. These are exactly the same because you've basically done exactly the same thing. So that is how we use the BPD function in the first instance.